66 million years ago, a large asteroid or comet collided with Earth and led to the extinction of dinosaurs. But what if this catastrophic event wasn't the only reason for their demise? In this video, we will explore whether there were other factors that contributed to the extinction of these giant reptiles and whether they would have survived if it weren't for them. Let's get started. The impact that led to the extinction of the dinosaurs is one of the most well-documented events in Earth's history. It all began when a large celestial body crater sits at the Yucatan Peninsula in Mexico. Measuring approximately 180 kilometers or 110 miles in diameter, this crater, known as the Chicxulub crater, holds the key to unlocking the secrets of this mass extinction. Scientists have estimated that the asteroid that caused it was approximately 10 to 14 kilometers or 6 to 9 miles wide, weighing an astonishing 4 to 5 billion kilograms. But what if this isn't the whole story? Some researchers suggest that the asteroid may not have been the sole cause of the dinosaurs' demise. Instead, they hypothesize that a series of smaller asteroids could be responsible, according to research published in the journal Scientific Reports in 2021. Using computer simulations, scientists have reconstructed the impact of the asteroid and its devastating effects. Their findings reveal that the asteroid triggered massive earthquakes that unleashed gigantic tsunami waves, leading to the destruction of coastal ecosystems and triggering a chain reaction that ultimately resulted in the extinction of terrestrial life. However, it's important to note that these simulations did not take into account volcanic activity, which some scientists believe played a significant role in the extinction event. As we delve deeper into this captivating topic, we will continue to uncover more about the crushing force of this catastrophe and explore the potential contributions of other factors to the dinosaurs' demise. The asteroid impact theory has been the dominant explanation for the extinction of the dinosaurs for several decades. The impact of an asteroid or comet of this magnitude would certainly have had devastating consequences for life on Earth. According to research, the impact energy of the asteroid released an enormous amount of kinetic energy, equivalent to approximately 10 trillion watts. Upon impact, the asteroid generated an intense heat, causing temperatures to soar to approximately 10,000 degrees Celsius or 18,000 degrees Fahrenheit. The immense thermal radiation emitted from the crater silently wiped out many species, even before the devastating tsunami waves reached the shores. Furthermore, the impact triggered massive earthquakes that rippled across the globe. These earthquakes, combined with the tsunami waves, obliterated coastal ecosystems and wreaked havoc on marine life. As the earthquake waves progressed inward, they caused extensive damage to habitats, leaving them bare and unyielding. In fact, the impetus of the asteroid impact was so immense that it severely disrupted the global climate system. The plumes of debris and dust rose high into the atmosphere, blocking sunlight and plunging the planet into darkness. This sudden and drastic climate change had profound effects on photosynthetic organisms, such as plants, algae, and cyanobacteria. The deprivation of sunlight led to the collapse of their energy-producing processes, resulting in widespread death. Additionally, the impact generated enormous amounts of carbon dioxide, sulfur dioxide, and nitrogen oxides, which were released into the atmosphere. These gases formed a thick layer of smog, further contributing to the habitable regions of Earth. The impact of the asteroid on the climate system can be compared to the worst-case scenario of anthropogenic climate change, highlighting the profound and long-lasting effects of this celestial collision. However, some scientists question whether the asteroid alone was sufficient to cause such a catastrophic extinction event. Instead, they argue that a combination of factors, including the asteroid impact and volcanic activity, contributed to the demise of the dinosaurs. Research published in the journal Nature in 2020 sheds light on the timing and duration of this extinction event, providing further insights into the potential role of volcanic activity. According to this study, the extinction event was more prolonged than previously thought, occurring over a period of approximately 300,000 years rather than the commonly accepted time frame of 6,000 years. During this time, the frequency and magnitude of volcanic eruptions showed a significant increase, particularly in the Deccan Traps region of India. The study indicates that the asteroid impact may have been the catalyst that triggered this surge in volcanic activity, leading to a cascade of events that ultimately resulted in the extinction of the dinosaurs. The timing of this event, approximately 50,000 years before the asteroid impact, highlights the potential link between the two phenomena. Volcanic activity, particularly large-scale eruptions, can have profound effects on the environment and climate. The release of large amounts of volcanic gases and aerosols into the atmosphere can cause significant climate change, leading to global cooling or warming, depending on the composition of the gases released. For example, sulfur dioxide can reflect sunlight back into space, leading to a net cooling effect. On the other hand, carbon dioxide is a greenhouse gas that can trap heat in the lower atmosphere, potentially leading to global warming. Furthermore, volcanic ash and debris can interfere with global weather patterns, disrupting precipitation and wind circulation. This disruption can lead to droughts, floods, and other extreme weather events that can have devastating consequences for life on Earth. One of the most prominent examples of the impact of volcanic activity on life is the event known as the Great Dying, or the Permian-Triassic Extinction event. This catastrophic event, which occurred approximately 252 million years ago, is considered the worst mass extinction in Earth's history. The primary cause of the Great Dying is believed to be the eruption of the Siberian Traps, a large igneous province located in Siberia, Russia. These eruptions released massive amounts of greenhouse gases and toxic chemicals into the atmosphere, leading to severe climate change and the extinction of approximately 70% of terrestrial and marine species. In the case of the asteroid impact and subsequent volcanic activity, it's possible that the impact triggered a chain reaction leading to the eruption of volcanoes in different parts of the world. The impact would have generated intense heat and seismic waves that could have reached Jiaodong, a region in northwestern India. This region contains a large number of active and dormant volcanoes. The heat and seismic energy from the impact could have triggered the magma chambers beneath the surface, initiating a cascade of eruptions. Alternatively, the impact may have caused significant changes in Earth's crustal deformation, leading to the activation of fault lines and the release of pressurized magma. Furthermore, the impact of the asteroid would have generated powerful shock waves that could have traveled around the globe. These shock waves may have reached the northwestern part of India at an angle of approximately 45 to 60 degrees. This angle is considered optimal for the initiation of volcanic activity. Additionally, the impact would have caused a rise in global temperatures, which could have triggered the melting of ice sheets and anomalous climate change. This could have created conditions conducive to increased volcanic activity. In conclusion, while the impact of the asteroid is widely recognized as a major factor in the extinction of the dinosaurs, it's possible that a combination of factors, including the asteroid impact and subsequent volcanic activity, played a significant role. The timing of the volcanic activity in northwestern India, prior to the asteroid impact, as revealed by recent research, supports this hypothesis. Further investigations into the link between the asteroid impact and the Deccan Traps volcanism may provide a more comprehensive understanding of the complex web of events that led to the demise of these giant reptiles. What if the dinosaurs hadn't gone extinct? How would the world be different today? We would love to hear your thoughts on this fascinating topic in the comments section below. Don't forget to like this video and share it with your friends and family. Your engagement is valued and encourages us to continue creating engaging and educational content. Thanks for watching.